Hey guys, today we'll be looking at probability. So I'm calling this an introduction because we're going to start with basics. So firstly, probability is a measure on the scale between 0 and 1. Let's make that line a bit bigger. So probability is a measure on the scale between 0 and 1. So this means it definitely will not happen. And if it's got a probability of 1, it will definitely happen. We call that a certainty. Yes, so we're certain it will happen. And then we measure accordingly. So if you flip a fair coin, there will be a 50-50 chance of it being heads or tails, which will put as a decimal as 0.5. Sometimes you see it expressed as a percentage or as a fraction. They all mean the same thing, and with words that we would say that has an even chance. Yeah, it is, I don't know, it's early March in England, so there is a fair chance it will rain today, maybe somewhere like that. Yes, about 0.3 chance. Yes, so that is the measure on the scale. So something is unlikely to happen, it will be in this region. It is likely to happen, it will be in that region. Now let's now then look at some questions. So here we've got a question where we have 6 counters. So let me draw my 6 counters. 1, 2, 3, 4, 5, 6. Imagine they're all the same size. And we're told that there is at least one count that's purple, one that's green, one that's orange. There are no other colours in the back. So the chance of a purple is evens. So we know half of them must be purple. There are more green than orange. Yeah, the chance it is green is more likely than orange. So we know there must be more green than orange. Therefore, we must have 2 green, 1 orange. So determine how many green counters is in the bag. The answer would be 2. Next one. Probability to roll a 6 on a biased dice is 1/5. Find the probability to get a number different to 6. So, how many sides are there on a dice? Exactly 6. Let me draw a wicked cube. There you go. See our 6 sides. So what it's saying is, let's imagine this, the bottom end is a 6. So since probability adds up to 1, the probability of not getting a 6 must be equal to 1 minus the probability of getting a 6. Well, the probability of getting a 6 was 1/5. And what's 1 minus 1/5? Exactly, 4/5, which is the same as 0.8 or 80%. So the probability to get a number different to 6 when rolling the dice will be 0.8 or 4/5. So again, we're using the same principles in this question. The probability Sam wins in the game is 0.2. So find the probability Sam does not win. What must the probability of winning plus the probability of losing equal? Exactly 1. So if the probability of winning is 0.2, so that's probably similar to the chances of Man United winning the game at the moment, and the probability of losing must be 1 minus 0.2. So again, we'll have 0.8 as an answer. First few questions, we've really used the fact that probability adds up to 1. So it can never be more than 1 or less. Yeah, once you've considered all outcomes, it should add up to 1. Let's go to our next one. Okay. Final question. So we're going to add some algebra to this one. So we have a spinner with 4 sides. And we've got the probabilities in the table. And it's told us the probability of purple is twice the probability as blue. So if the probability of getting blue is X, purple is double that, which would be exactly 2X. So we know all these should add up to 1. So now we can write an equation. So we have 2x plus x, which is 3x, plus 0.3. Let me just write it out, actually. So I have 2x plus x plus 0.35 plus 0.05 equals 1. So 3x plus 0.4 equals 1. So if we rearrange this, we take away 0.4 from both sides. So 3x equals 0.6. The opposite times in by 3 is dividing. So x is 0.2. So if x is 0.2, 2x must be 0.4. So now we can complete the table. And we are done. So that'd be 0. Forgotten which one was which. Probably purple's twice as likely. Oh, Jesus. Yeah, hope that makes sense. Yeah.